Hi guys, so now that we've gone through acids and bases and pH, we're moving on to the reaction that occurs between an acid and a base. And this is called a neutralization reaction, and it's a specific double displacement reaction which we've already learned about, so that's great, but we're going to go through what specifically happens when you react an acid and a base. So for neutralization reactions, there are two types. Where the reactants are an acid and a base, and they will produce a salt and water. Now, when we say salt, as in a general term in chemistry, we mean an ionic compound. We don't mean salt as in table salt, which is NaCl. We just mean the product that will be produced is an ionic compound, so that's important to note. The second type is when you have carbonate and acid as the reactants, where carbonate is a compound that contains the polyatomic ion CO3. And then these two reactants will produce a salt again, plus carbon dioxide and water. So those are the two basic forms. So clues for you to identify whether a reaction is a neutralization reaction are one reactant is an acid, but just because a reaction is an acid doesn't always mean it's a neutralization reaction. It's just a clue that it may be a neutralization reaction. Another clue is if you have a carbonate as a compound, a reactant that's a carbonate compound. And another clue is one of the products is water. So these are just some tips to remember in order to identify. So now let's learn how we would predict the products if we had the two reactants. So here we have hydrochloric acid and calcium hydroxide. So what you would first do is you take the cation of the first reactant, so in this case hydrogen, and add it to the anion of the second reactant. So that would be the hydroxide, the OH. That's the first step. Second step is to take the cation of the second reactant and put it with the anion of the first. So that would be calcium and chlorine. And once you do that, you are going to remember to always write the cation first, positive charge first, and you have to balance the charges with the subscripts. So you have to look at the charges on the periodic table and make sure that they're balanced. Now, you keep the subscripts if they are part of the original polyatomic ion. So in this case, we don't keep the 2 because it's not part of the formula for hydroxide. And so here's our answer. We have the cation from the first reactant plus the anion of the second, the cation of the second reactant plus the anion of the first. And we balance the charges out and it's all set. Now HOH that was just to show you how to get the cation and the anion. That's water. You can write H2O with that. So now we're going to try this on our own. So here are your reactants. I want you to pause the video and try it on your own and come back and see what we get. See if your answer matches what we got. Alright, let's see how you did. Here are our products. We have sodium sulfate and water. So hopefully you got it right. We took the cation of the first plus the anion of the second, and then the cation of the second plus the anion of the first. Here's number 2. So again, pause the video, do it on your own, and come back and check to see if you got it right. Here are our answers. How are you doing so far? And lastly, here we go. This is the third one. Pause this video yet again and try it on your own and then come back to it. Alright. And there are your answers. So we have already been exposed to a double displacement reaction. So these neutralization reactions shouldn't be too difficult for you. We're going to do some problems in class, but this is just to introduce you to it.